students, welcome you all on Engineers Career Point. So my dear students, if you are preparing for GATE 2024, either you are from the third year or the final year, this video is very important for you, because in this video we are going to discuss one important topic for GATE point of view, in which you may face at least one problem. So today we are going to discuss the binary search. As I know, you know what is binary search, what's the time complexity, but keep in mind, my dear students, GATE play with you. Like, he asked some questions in such a way that you are thinking like we can apply the binary search on that particular problem, but it may not be the case. Fine. So in this video we are going to discuss about the logic of binary search, when we apply binary search, and we are going to see some of the problems where we can apply the binary search and we cannot apply the binary search. So stay tuned with us. So today, first start with the logic or the concept of binary search. As we already know, binary search, it is a searching technique. Fine. It is a first point is it is a searching technique. If we want to search something, then we can apply binary search. It is a searching technique, but the constraint for apply the binary search is input should be sorted. Our input should be in sorted order. Our input should be in sorted order. Fine. So now if we want to search something where input is sorted, then how binary search behaves. So if we talk about, suppose we have an input. We have an input 10, 20, 30, 40, 50, 60 and 70. And if you want to search an element first, that is like 40. So as input is sorted, so how we can apply the binary search? To apply the binary search, first of all check or find the middle element. Mid element. How we can find out the middle element? If we talk about the indices, that is 0, 1, 2, 3, 4, 5 and 6. So if we talk about the mid element, that is 6 plus 0 by 2, that is 3. 0 plus 6 by 2, which is going to be 3. So now check A of mid. Suppose A is the given array. So A of mid means A of 3. What is A of 3? 40. Is 40 is equal to x? Yes. Is 40 is equal to x? X is my 40 again? Yes. So return. So return the index 3, that at location 3 the element which you want to search is present. Fine. Return yes, or return I. But in the second case, if we talk about the second case where we want to search an element which is not present in the middle. Fine. In the previous case, if we talk about how much time it will take, just find out the middle element, that is A of mid. It just take constant amount of time, plus we have to perform a comparison that x is equal to A of mid or not. Again it will take just constant amount of time. So hardly it will take, in best case it will take constant amount of time. Fine. But if we talk about the worst case, in worst case, see now the logic start. In the worst case, if you want to search an element, which is like 100, then how you can proceed? Find the middle element, that is the 40. Is 40 is equal to 100? No. First thing. Second, just do one more comparison, then that is 100 is greater than 40 or 100 is less than 40. 100 is greater than 40 or 100 is less than 40. If 100 is greater than 40, it means the element which you want to search is greater than the middle element. Then you have to apply your binary search on the right hand side subarray. Fine. It means you have to apply the binary search on this array. And if 100 is less than 40, fine, or I can say the element which you want to search is less than 40, then apply the binary search on left hand side subarray. Fine. That is on this array. But in my case, as x is 100, I want to search an element 100 which is greater than the middle element. That's why I want to apply the same procedure on the right hand side subarray. Fine. It means no need to do any task on these elements, and these number of elements are approximately n by 2. It means with constant amount of time, within the constant amount of time, I am able to take a decision that these n by 2 elements are of no use. Fine, great. Again start the binary search, find the middle element. 6 plus 4 by 2, that is 5, which is going to be 60. Again, is 60 is equal to my 100, that is x? No. Is 60 is less than 100 or 60 is greater than 100? Same, as 100 is greater than 60, so apply the binary search this side. Now no need to perform any comparison on this element. Fine. Again, whatever the element we have on the second iteration, when we start my second iteration, whatever the number of element I have, with just compare with the middle element, I am able to get a decision that I have to remove the n minus 2. What is n? The current input size. So I have to remove these n by 2 elements, and for the next input I have just to consider the next n by 2 elements. Fine. In this way, if I talk about the recurrence relation of binary search, initially I want to search an element on an input size of n. So what is T of n? T of n represents the time required to search an element when input size is n, which is sorted in nature, and I am just trying to apply the binary search. Fine. Then after performing some constant amount of task, I am able to get a decision that okay, I have to apply the binary search again on these n by 2 size array. So if we solve this recurrence relation, this is going to be T of, so what is the value of T of n by 2? So that is T of n by 2 square. You know how to solve the recurrence, and 1c plus c is 2c. In this way, if I talk about, if I go with the k times, then n by 2 ki power k plus kc. So I am considering let L is equal to 2 ki power k. I am not going in depth in this case because you know how to solve the recurrence relation. If you have any doubt, you can put on the comment section box, and then I'll give you the detailed explanation of this recurrence relation. So this is going to be n upon, if I put 2 ki power k as n by n plus kc. Fine. So T of 1, that is n by n is 1, T of 1, as I know, this is the base condition, which is going to be 1 plus c dot k. If I find out the value of k, take the log both side, so log n becomes k. So the value of k is log n, so I can say 1 plus c dot log n, which is going to be big of log n. Fine. That is a simple case. That is the logic of binary search. Now the point is, what type of question in GATE you may face. That is the important part of this video. So my dear students, so I'll just explain you two problems. Suppose first problem is this. I have a input that is 10. A input is sorted in nature. Fine, or I didn't take the static input. So the problem statement is an array of n element which is sorted. Output, what we want, find the index of element x. Find the index of element x. Fine. Note x is present in array. X is present in array. So if x is present in array and input is sorted in nature, we know that we just apply the binary search. Why? Because just find the middle element. Is mid is equal to x? Yes or no? If yes, just take constant amount of time, else either move on the left hand side part or the right hand side part, but not on the both side. Keep in mind. It means if my element is not the middle element, then I am able to take a decision that either I have to go on the left sub part or on the right sub part. So it will take log n time, because that element is present and that is given to us. The x element, an array of n element which is sorted and given target element and given x. So the point is, the element which you want to search is given to you. Keep in mind, the element which you want to search is given to you. Fine. But now suppose that you may think, like, whenever we have a sorted input, and if we want to search something, then always we can apply binary search, but that not be a case. So like, suppose we have a problem. The problem is, I have a sorted array. Fine. Sorted array of n element, out of which n minus 1, or I can say n minus 2 element are distinct and one element came 2 times. So I just take an example, like I have some elements. So input is sorted, that is 10, 20, 30, 40, 50, 60, now 70, 80 and 80. So it means one element came 2 times and the remaining element are distinct and sorted. Fine. Now my task is to find the element which is repeated, which comes 2 times. So now, my dear students, you are saying that yes sir, input is sorted and we want to search a element. Keep in mind, my dear students, here key is not given, that the key is 80, 20, 10, 30, key is not given, but they want to search something. What they want, please search an element which is repeated in the nature. Fine. So in this case, if you are trying to apply the binary search, then 10, 20, 30, 40, 50, 60, 70, 80 and 80. Just find the middle element. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 plus 0 by 2, that is 4.5, or you can say 5. 50. So now how you can approach? Middle element is 50. Now check the neighbors, because if input is sorted, then adjacent element are same if they are repeated in nature. Fine. So check 50, 40 is equal to 50? No. 50 is equal to 60? No. It means 50 is not the element which is repeated in nature. Fine. Now where you can move? Either you can move on the left hand side or the right hand side. Are you able to take such that decision that you have to go to the left subarray or on the right subarray? No, we cannot take such a decision, because we don't know that the repeated element present on the left subpart or on the right subpart. So keep in mind, my dear students, in this case, by seeing the question, you may face that, yeah, input is sorted, we want to search something, it means we just apply the binary search and A option is log n, you just mark that particular options. But that is wrong. Why? Because you are unable to take a decision after compare with the mid element that either you want to move on the left subpart or on the right subpart. If you are in a position to take a decision every time after finding the middle element that either you select the left subarray or the right subarray, then you can say that yes, it will take log n time. But at this moment of time, as you are not able to take such a decision, it means you have to apply the binary search and find out the element and their adjacent. Fine. So this problem take order of n time, not the log n time. So my dear students, please try to solve such type of problems. Maybe this topic is very easy, but my dear students, GATE play with you. Okay, so keep watching these such videos. We are regularly uploading all these stuffs. Please follow us, and if you have any doubt and if you want to join the GATE 2024 preparation, so you can contact to Engineers Career Point. We have the dedicated batch that is for offline as well as online. Fine. Thank you so much.